So dear participants, let's move to experiment number 5 of section 1 IAVOC 305. In this particular experiment, we are going to see that how to interface an LM35 temperature sensor to Arduino UNO, and we have got two objectives to be covered within this experiment. Under objective 1, we are to simply print the temperature that has been detected by the sensor in serial monitor of the IDE, and in the second objective we need to activate a relay if the temperature is beyond a given threshold value in the code. Now see here that during demonstration you will find that I am not going to use a relay. I will simply use an LED to show the actuation, to demonstrate the actuation, and it is kept as an assignment for you that you kindly connect a relay to the circuit and see its operation. How to connect and the complete conception about working of a relay and a relay module is provided in the manual. Another thing that I would like to add, that before you perform the experiment, you kindly go through the datasheet of LM35, at least the major parts, important parts, because you will get an idea about the capacity of this very precision temperature sensor that is used extensively for temperature sensing applications. The equipment or components that are required for this particular experiment are simple. Well, we need the desktop or laptop for programming the UNO. You need a UNO prototyping board, USB cable, A to B type, then LM35 sensor of course. You need a relay module, or you can simply use a relay along with some components that are required as its driver, and you need male-to-male jumper wires as well. So before you get into the sketch or the actual circuit part, let us get a brief introduction to the different components that are used here in this experiment. First one is LM35, which is the heart of the circuit. It is a precision centigrade temperature sensor. I will go through the basic features. These are the most important features that I have taken from the datasheet of the IC itself. You can see that it is factory calibrated in Celsius. So whatever voltage that we are getting at the output of this sensor, it is calibrated in centigrade temperature scale. This is one very beautiful aspect of LM35, that you need not to go for any external calibration. So far you want to measure the temperature in terms of centigrade. You can see here that it has got a very wide operating range from minus 55 degrees Celsius to 150 degrees Celsius, and its linearity is excellent. You can find that the scale factor is so simple. For each degree centigrade increase or decrease in temperature, the voltage changes across the output pin to a tune of plus or minus 10 volt. So if the temperature is increased by 1 degree centigrade, the output voltage will be increased by 10 millivolt. Likewise, its accuracy is also very precision, that is 0.5 degree centigrade, and it is a low cost IC. Its operating voltage range is also very high, from 4 volt to 30 volt. Its self-heating phenomenon is also very low, very marginal, and non-linearity is also very low. Now you see, for this particular experiment we will be using the 3-pin TO92 low power package. This is the plastic package you can see. This is how the IC will look like. You can see there are 3 pins. If you look from the bottom like this is the bottom view. The leftmost pin is the supply pin. The center pin is the analog output from which you are getting the temperature value in terms of millivolt. And finally, the rightmost pin is the ground pin. Okay. Next comes the use of relay. Now, why we are using a relay and why relay is coming into the figure, that we need to understand here. Suppose the temperature sensor is connected to a heating module or a heater, maybe a small heater or a small furnace to which the temperature sensor is connected, whose temperature has to be monitored. Now, many a times it happens that monitoring is not the only requirement. You need to control the temperature as well. So when you want to control the temperature, then relay comes into the figure. See, if suppose you are using a heater that can be heated up to 100 degrees centigrade. Now you want that once the temperature of 70 degrees centigrade is reached, then the heater should be stopped, and if the temperature of the heater goes below 65 degrees centigrade, then it should be again powered on. Now this is a most simple case I am talking about. In your control systems paper, you have gone across various control methodologies like bang bang control or PID control, simple PI control. All these things you have done. I am not getting into those details. Very simple thing I am talking about. So there you can very easily use a relay. The temperature sensor will sense the temperature. That temperature will be going to your code. The code will help you to get the temperature, and with the help of that code you will design the code in such a manner that if a threshold temperature is reached, then the relay will be activated or deactivated. You have used enough number of relays in your earlier experiments or projects. That's why I am not getting into the details of the operation of a relay, because it's pretty simple. There are, in normal case, this is a typical relay. You can see here there are 2 coil pins. You need to give the signal across this coil. One of the coil terminals will be going to ground and other coil terminal will be provided with the signal. Then there is a common terminal, there is an NC terminal, and there is an NO terminal. In normal condition, the common terminal is connected to NC. Okay, that's why it is normally connected. If you give a signal to the coil and the coil is activated, then you see this common terminal gets connected to NO. Alright, so now you see that with the help of such an electromagnetic device, you can very simply put some device. It may be a small bulb, it may be some load, maybe a fan, or in case this temperature sensor, we can talk of an heater. Okay, so you can connect the heater to the normal open terminal. When required, it can be put on. When required, it can be put off. So this is very simple. Now you see, I have given, or this manual contains operation of each and every pin. The features of a normal 5-volt relay, typical 5-volt relay, is also given here. You are requested to go through the same. I will give the link at the discussion section. Now you see that if you are using a simple relay, not a relay module, that is very common with Arduino based projects, you can have directly a relay module. If you are planning not to use such a module and you are going to use simply relay, be very careful that you should not connect the relay directly at the output of the Arduino pin. That means the coils should not be supplied directly from the Arduino. You have to use a driver circuit because the coil requires pretty good amount of current. So if such is the situation, you can see here, this is the driver circuit where you are using a switching transistor. Now, if you need a very heavy load, you can think of a MOSFET also. You can think of a Darlington drivers also. Here I have just shown example of 2 and 2222 transistor. You can also use a CL100 or SL100 if it is up to maybe 950 milliampere of load current that is required. Now you see here you need to connect the coil of the relay in open collector configuration of the transistor, and to the base you should supply the signal from Arduino pin. Alright, and you have to give a base resistance to control the base current, so that the base current is contained at a very low value. And another thing that you should use that freewheeling diode. You can see this is an antiparallel diode that is connected to the coil, so that whatever, since this is an inductor, it after it is switched off, it contains some charge. Okay, so in order to wheel the charge within the coil itself, the freewheeling diode is used. So you should not forget to use such a circuit when you are applying a relay. Okay, you need to get your driver. Now I have written the role of the switching transistor, the freewheeling diode, so that you can be very sure about their operations, or you can use such a relay module. Using a relay module is pretty simple. You need not to go for anything. You need to connect the ground terminal to the ground pin of the UNO board. The signal terminal should be connected to that particular pin of Arduino. Definitely it should be a digital pin that you would like to use as the actuator pin. Then you need to give the VCC, which should be connected to 5 volt. Okay, now you can see here that why I am saying 5 volt, because you can see the relay is having its coil 5 volt DC coil. Okay, now the NO terminal, the common terminal and NC terminal, they are typically provided with such screw based terminals, so that you can make your connections easily. All right, you can see here this is the circuit where you can see that in the common terminal we have connected the phase of line, that is the line 220 volt line you can put here in the common terminal, and NO terminal can be connected to one terminal of this holder. The neutral terminal can be directly connected to neutral. So whenever you require, then the bulb will be on. Now you can see here the utility of this relay. Your Arduino UNO is working at DC 5 volt. You are using that Arduino to control a AC incandescent lamp. Yes. So for that you are using the relay. You are supplying the low voltage signal of Arduino only to the coil of the relay, and that is ultimately operating the NONC contacts and your load is working. So this is the operation of the relay. So you can see here that I have also given that operation of each and every pin of the relay module. Now let us directly go to the circuit diagram. You can see here how we can connect the LM35 sensor to the Arduino. Alright, so that we can get the reading in serial monitor. You can see here that very simply the LM35 has got 3 pins. One is VCC, other is ground, and final is the signal. Okay, so you see here that these 3 pins we are connecting to the Arduino UNO pins. How we are doing that? Let us get into action. You can see here that as I had already discussed, the LM35 VCC pin is connected to the 5 volt pin of the Arduino UNO board. The ground pin is connected to the ground pin of the Arduino UNO board, and you can find that Arduino pin A3 is connected to the output pin of the sensor. Remember here that any of the analog input pins can be well employed for this purpose. You can use any of them. Since I have used in my code A3 pin, that's why I have given it like this. Now comes how to activate a relay. If you want to activate a relay, then you can see here that the LM35 circuit and the relay circuit, they are independent. However, they are connected to the code. You can see that 5-volt terminal will remain the common terminal. You can see here that is the common terminal of 5 volt. That 5-volt terminal is connected to LM35 as well as 5-volt pin of the relay module. The ground is connected to the ground pin of the relay module and LM35 ground. And finally, you can see this LM35 output pin is connected to A3, pin number A3. Sorry, it has been mistakenly written. I think no. Okay, real number. Yes, you can see LM35 voltage output to Arduino pin A3. And here we are using pin number D2. That means digital pin number 2 to the relay uh, input, I should say relay activation pin. You can see in this relay module, if I get to a relay module, you can see there is a signal pin. So this signal pin is connected to digital pin 2. That is all about the circuit. So let us now try to build the circuit and see how the operation takes place. Only you need to remember that during this building of the circuit, I will not be connecting a relay module. That has been kept as an assignment for you. I will be directly connecting an LED. Alright. Now let us get into the circuit. You can see here, this is the circuit in which you can find this is the LM35 IC. I will be putting on the light so that you can see here. You can see here this is LM35. As I had already discussed, there are 3 pins. The leftmost pin you can find, it is given to VCC. The center pin is the output signal pin and the rightmost pin is the ground pin. Alright. Now you see here, I have kept one LED connected and one series resistance to the cathode of the LED so that I can directly connect it to ground, so that the LED is not supplied with excessive current. So now let us build the circuit. This is going to be a very simple circuit. Alright, you can see here that this is the 5 volt. I will put it here so that you can have idea. Put off the light maybe. Okay, now you can see this is the 5 volt pin. The 5 volt pin I will be deploying for giving necessary power to the LM35. So here goes the 5 volt connection to the LM35. You can find next the ground pin. You can see here, this is the ground pin. There are 2 ground pins in UNO board. This is one of the ground that we will be deploying. So you can find here, or I will be using a black maybe for the ground. So here I have connected the ground. You can see here this is ground connected. And finally, I am to connect the output pin of LM35 to the analog pin. Now we are using analog pin number A3. So you can see this is pin number A0, A1, A2, A3, A4 and A5. So I'll be using A3 here. So you can find the connection has been made. I will be putting it here, or maybe here, right? So now you can find the simple circuit for connecting the LM35 is ready. Here is our LM35. You can see here there are 3 pins. This is the VCC, the center pin is the output pin, and the third one is the um, ground pin, rightmost pin. Okay, so we will be working with this basic circuit, and we will see that how to generate a code by which we can simply read the temperature by using this LM35 sensor. So for that we will be opening the IDE. I have already kept the code ready. So this is sketch for LM35. Now see here that initially we have declared the variables. Now what type of variables we have used, that we have to understand first. You see here the first line is int, that means integer. We have taken a variable sensor. This sensor is nothing but the reading that we are getting from at pin A3. That is the output of LM35 that we are getting at A3, that we have declared as sensor. Next there are 3 variables, TEMPC, that means I have taken it to be temperature centigrade, then TEMPF, temperature Fahrenheit, and the output voltage V out, simple output voltage. These are the 3 variables. Now you see here the difference between the variable sensor and the variable temp C, temp F and V out. All of them are of float type. Temp C, temp F and V out all are of float type. Now what is the goodness of having a float type? By that time you might have known that we use a float type data when we need a decimal value. So here we need decimal value for both the temperature reading in centigrade scale and Fahrenheit scale, and also the output voltage of the sensor, that should be in decimal format also. That's why in each case the variables have been declared as float type. Now in the setup part we have gone for pin mode declaration, right? Pin mode function, sorry. In pin mode function we have given the sensor. You can see the sensor variable, it's an input function. That's an input parameter. That's an input parameter. Next we have given serial dot begin because we want to use the serial monitor, and therefore the baud rate has to be declared. This is 9600. Now comes the loop part, which is the actual execution part. Let us try to understand each and every line clearly. First of all, you see we have defined V out. The V out was a float type variable. This is a float type data will be there in this variable. So this V out we have made it to read the value at pin number A3. Now you see pin A3 is the sensor actually. We have named it sensor. We are getting analog read function for V out. Now you see what we are actually getting there. We already know that when we go for analog read, we get values from 0 to 1023 because this is a 10-bit ADC. So that we will be getting at this analog read value. Now we are redefining this V out. You can see this V out is equal to this value that we are getting out of that ADC into 500 divided by 1023. Now here there is a trick. What is the trick? You can see why it is 5, because maximum input voltage that is that can be read at A3 is 5 volt. Now you have seen in the data sheet of this LM35 that it gives out 10 millivolt for a change of 1 degree centigrade. It's 10 millivolt for 1 degree centigrade. Now you see here 5 volt. 5 volt means 5000 millivolt simply. And if I want to scale it to 10 millivolt, for 1 degree centigrade it is 10 millivolt. So how much this 5000 will give? You can see it is 5000 divided by 10, that is up to 500 volt. So therefore each step of the ADC, because ADC goes like this 0, 1, 2, 3 up to 1023. So each step will generate 500. Why it is not 5000? Because it is 10 volt per degree centigrade. Therefore 500. 500 divided by 1023. These are the number of steps degree centigrade. So each step will generate 500 divided by 1023. Now as this is directly calibrated in degree centigrade, there is no problem. We can have temperature centigrade is equal to V out. Fine. Next comes temperature Fahrenheit. Here you can see that centigrade value has to be transferred or converted to Fahrenheit value. How can we do that? Very simply, you use the formula. If the value of temperature is centigrade is given as C and temperature in Fahrenheit is given as F, then it will be, the formula is C divided by 5 is equal to F minus 32 by 9. C divided by 5 is equal to F minus 32 by 9. So that formula you apply here. You develop this simple equation and you will convert the Celsius value to Fahrenheit. Now only the process of printing these values in serial monitor remains. For that, what we will do? First, we will write serial print. This is the serial print function in which within the inverted comma it is in degree centigrade is equal to. Then serial print within inverted comma in this by this symbol. After that, followed by T, right? This is temperature. Serial print temperature C. Serial print temperature C. That means whatever the value of temperature C in degree centigrade will be there, that will be printed here. After that, there is a space, line break is there, and then again it's in Fahrenheit. Then this slash signal symbol and this T, that means Fahrenheit temperature. This is just, you can remove this slash and T also. There is no problem. Just I have done that to show this is the temperature. Okay, and you have to print temperature in Fahrenheit. Finally, again there is a line break and we have given a delay of 2 seconds. 2000 millisecond means 2 seconds. I should not write 1 here. This will be 2 seconds for ease of viewing the change. All right. So let us now try to load it to the Arduino. So we will compile it first. The verification is done. Okay. We will load it to the Arduino. I had already connected the Arduino to the COM3 port of my PC. So now it has been loaded and let us try to see here. I will go for serial monitor. You can see the temperature is being reflected. There is some problem with the connection of the thing because it's absurdly high temperature. Okay, now you can find. You can see the temperature is being reflected in degree centigrade, and simultaneously in Fahrenheit also. Alright, there is tremendous fluctuation because I have kept it in front of an oven sort of thing for showing the changes. I am moving the oven in and out, and you can see this is how the degree centigrade value and Fahrenheit value can be very easily seen in serial monitor. You can see also in the camera, this is the view, this is your sensor, it is simply working. Okay, and this is the view of your serial monitor. All right, now what I will do, I will make the situation now a bit more complex. Now I will going to explain the particular sketch that you will be using for controlling a relay. Now, as I had already told you that I will not be using a relay for our purpose. For that I have used simply this LED. The LED will be connected to one of the digital pins of UNO, so that when the temperature is beyond a certain value, now you can see this is 37 degrees centigrade right now, 37.63, and in Fahrenheit it is 98.86. Okay, now we will be giving a value, a threshold value, so that when the threshold value is crossed, when the threshold value is crossed, you can actuate a relay or you can deactivate a relay. So how that will happen, let us try to see. So I will be going to another code right now. I will be putting off the serial monitor and we will be going for another code. So you can see here, this is the LM35 sketch. I'll be opening LM35 relay. So you can see here that here I have developed the program maybe in a different manner. Now why I am doing this? Why just for reading the temperature I am not using the earlier program? You can use the earlier program also, and after that you can use the if else statement. You can use the if else statement, that you can use definitely. But here I am showing the program in another way, so that you can see that any operation can be done with sketches developed in different manners. However, the objective should be clear. Here I have gone for, you can see, three declarations at the beginning. These are global variables. One is val, that is the value, which is an integer type of data. Then there is temp pin, which is A3, which is again an integer type of data. And there is relay pin, which is again an integer type of data. The relay pin is connected to pin number, digital pin number 2. The temp pin is connected to analog pin number 3. Connected means not in the sense connected, but it is the name of the variable. I should not say connected. These are the three variables. Okay, val is a variable, temp pin is a variable, relay pin is a variable. Now relay pin is nothing but pin A3, temp pin is nothing but pin A3, and relay pin is nothing but pin D2 for the Arduino UNO. These are the three variables. Okay. Now what I will do in the setup part, serial begin will be used because we are using a serial monitor, so baud rate has to be declared. Then the serial print line has been used. So there will be written LM35 test. Okay, so this is simply a code. LM35 test will be printed onto the serial monitor. After that, I am declaring the pin mode. Okay, for relay pin, the pin mode function has been applied here. For relay pin, we are saying that this pin is acting as output pin, and initially I am writing low to the relay pin, so that initially the relay pin is tugged at digital low. That's why I am using this digital write function to write onto the relay pin a low value. Now comes the loop part, which will be actually executed continuously throughout the operation with the UNO. You see that we had used the variable VAL. Now that VAL is declared here, okay, as analog read the temp pin. Temp pin means we are getting the reading at A3. So we are using here the analog read function. The same thing we had used earlier also, only the variable names has been changed. Now you can see here we have invited the float type of variables. The variables which are having data that are of float type, because we want our result to be in decimal. Alright, now you can see I am to convert this value, because again this value is something in between 0 to 1023. It can be 1021, it can be 976, it can be 842, it can be 786, it can be 317, like that. Proportional to the temperature the value will be. Alright, and why it will be proportional to the temperature? Because your LM35 is actually giving out a voltage that is proportional to the temperature. That voltage is read by the ADC of your UNO, and that ADC output will be something in between 0 to 1023. Now let us go for this MB. What is this NB? MB. MB is nothing. I have just tried to give you the idea that what is the actual output at the output pin of LM35. So that value is given in millivolt simply. So you see in our earlier experiment, in earlier sessions, we had used here 5 divided by 1023 into value. It was 5 volt, but here I have deliberately given 5000 so that we can see how much millivolt is generated at the output of the sensor. Next, we can very simply decide what is the Celsius temperature, because each millivolt, sorry, 10 millivolt means 1 degree. 10 millivolt means 1 degree. So we can easily divide the value of millivolt by 10 to see how much degrees are at the output of the sensor. So what is the temperature? You can decide in Celsius very easily just by dividing the millivolt value by 10. Here I have made it more clear in this particular sketch. After that, you have to go for the Fahrenheit value. For that, you can again use that same formula. C by 5 is equal to F minus 32 by 9. So using simply by rearranging the equation, you can have the Fahrenheit value. Now here the Celsius value is given in CEL, and Fahrenheit value is given with the variable FARH. Okay. Now we will simply go for the protocols that we have to use for printing the values to the serial monitor. First, you can see serial print analog value, that is in bracket. So analog value will be simply printed. After that, it will be printing the value, this val, that is the output of the ADC. 0, 1, 2, 3 integer values will be there. After that, there is a line break. Then it will be printing temperature in Celsius, and after that temperature in Fahrenheit. So after this, after it is printed, the Celsius value is printed, the inverted comma, this asterisk, this star sign and C, that will only be showing degree centigrade, nothing other than that. And then there is a line break. We have given a delay before the Fahrenheit is printed. Again we have used this start sign to show the degree, and it is F. All right. Now here up to this, it is very clear that the values of ADC output, the values with Celsius value, Fahrenheit value, they will be simply printed onto the serial monitor. And finally, we will be going for the relay or any device control part using the temperature value. Here you can see what we have written. Here we have simply used the if else function or if else statement. You can see if cell, that means Celsius value, we will be getting the Celsius value for our comparison purpose. If it is greater than 39, I will change it a bit, maybe I can make it 42. So if the temperature is beyond 42 degrees centigrade or it is more than 42 degrees centigrade, then what will happen? In the serial monitor, it will be printed actuate, so that it is just a symbol to show the relay has been actuated or the LED has been actuated. Then there is a line break, serial print line, and then we will write on the relay pin. Relay pin is nothing but digital pin number 2, relay pin to be high. That means if the centigrade temperature value is more than 42 degrees centigrade, make the relay pin high. Else, you serial print no actuation, then serial print line break and digital write relay pin low. That means if it is beyond 42 degrees centigrade, you make the pin high, and if it is below 42 degrees centigrade, make it low. And after that we have given a delay of 3000 millisecond, that means 3 seconds, because we need to create a delay to see the changes. So this is all about the code. Let us now try to see the operation. Now I will verify it. Okay, there is no error, and we have to go for connection of the LED because we had not done earlier. Now I had prepared the things. You can see here that this is the anode of the LED. This is the anode of the LED and this is the cathode. To cathode we have connected a series resistance, and that resistance we will be connecting directly to ground. So I'll be using the ground here. I've used the ground here, and so you can see that ground is connected to the resistance is connected to the cathode of the LED. All right, fine. Now you see here, this is pin D2, this is pin D2, and this D2 will be connected here. This D2 will be connected here, and this D2 is connected directly to the anode of the LED. D2 is connected directly to the anode of the LED. Alright, you can see here. This is the anode of the LED, and here D2 is connected. So now we will see the operation of the circuit. We will go to our sketch. This is the relay. We will load, and we will go for the serial monitor. Now you can see here, now the temperature is 45.45. So you can find the actuate signal is there. Why? Because it is more than this 42. I will go for the operation of this thing also, and I will be giving the serial monitor so that you can verify the thing. You can see the temperature is right now 47.41, so it is actuated. So we will somehow try to lower the temperature. Now you can see it is 28.84. Since it is 28.84, you can see no actuation is being given and your LED has stopped glowing. Now I will raise the temperature. Actually there is some loose connection with the LM35 and that's why it is giving some spurious value. Now it is working properly because it is the room temperature right now, something around 30 degrees centigrade. And now I will be using this soldering iron. This is a hot soldering iron and I will try to raise the temperature. I have kept it very near to the LM35. You can see the temperature is raised and you can see immediately the LED is on because it is more than the threshold value. I will remove the temperature, this temperature source, that is the soldering gun. You can see the temperature is right now lowering. Definitely it will take some time because thermal inertia is there. Immediately it will not go down, but you see the temperature will lower with passage of time. We will wait for a while. You can see the temperature is lowering down by steps, but still it is beyond the threshold value. That's why the LED is on. Now there is again, it is doing some spurious action that I have to see. Anyway, if the temperature uh, because this sensor is lower than the threshold value, then the LED will be off. There is some problem with the sensor. There is I will try to get rid of this problem. Maybe here, because I have removed the source of temperature. It should not behave like that. This happens actually. If there is some loose connection, now you can see the temperature is lowering. Yes, it is gradually decreasing. Again, it is increasing. I don't know why it is happening, but it shouldn't happen like that, you know. It should gradually decrease right now because there is no temperature source. Maybe some problem has been developed with the LM35, maybe, or may not be. But let us wait for a while to see. There is definitely some problem. Now you can see the LED has gone off and proper temperature is also being displayed. 29.33, that is the room temperature. Again, I will bring the temperature source. You can see I have brought the soldering gun very near. The temperature is increasing. Definitely some time will be taken by the sensor to read the temperature value. Now you can see the threshold value has been passed and therefore the LED is on. Now I have removed the temperature source. In this case it was the soldering gun and you can see the temperature is gradually decreasing. Now you can see the LED should go off if the temperature further decreases. Now you can see when the temperature is decreased below the threshold value, the LED has gone off. So you can see here it should work well. There was some problem with maybe some loose connection was there within the breadboard. It happens, you know. That's why I do not prefer the breadboards, but still for this prototyping application, breadboard is a good option. You can see here the LED should go on. Now you can see the temperature is decreasing gradually. Definitely when a body is heated now, it takes some time to get cooled. So therefore the sensor will also behave like that. Now you can see the gradual decrease is there. The pattern is very clear. Now there is a problem. It shouldn't happen like that. It should decrease. Can you see that? Some fluctuations are there, but it has not decreased. So this is all about the operation of LM35 and how you can actuate a relay actually. Now you can see that here we have simply used this LED, but for the same pin can be used to drive a transistor, and collector of the transistor can be connected to the coil of the relay, and very simply you can operate a relay with the help of the same circuit and sketch. So that is all about this experiment. Whatever your confusions are, I request that you kindly put in comment box so that we can collectively discuss on that. Thank you.